Imbalanced data is where one category of your data has fewer samples than the other category. So take, for example, the blue dots and the orange dots. As the number of orange dots decreases, that becomes the minority group. You have 2,000 blue points, 2,000 orange to start with, and then you see it go down to about 50 on the orange. Now the problem with this is that the classifier naturally has a boundary here at 0, 0. That's where it should be. But as you decrease the number of points, this boundary for the classifier starts to shift the other way because it's trying to equalize the number of misclassifications. It's trying to say we want the blue dots that are on this side of the line to equal about the number of orange dots on this side of the line. And so that's how you train the model. But this creates a boundary that isn't correct just because you have fewer samples of the orange. So we're going to talk about ways that we can fix that problem with unbalanced or imbalanced data. So the two ways that we can do that are by either oversampling the minority group or undersampling the majority group. So take, for example, this boundary right here between the two. So what we're going to say is that we want to move this over to the left and have it correctly have something that's right in the middle for the classifier. And so you can see that we've done that here. And we're going to show how to oversample or undersample. So even though we only have 50 points here for the orange, we're still going to weight those in a way by either removing some of the blue, or we're going to add additional orange points that are derived from the existing orange points. And that would be the oversampling. And the one on the left, if we remove some, that would be undersampling on this side. Okay, so let's just start with a blank notebook and go through some of this just to, first of all, create our data set, okay, the balanced or unbalanced data set, and then we'll work on using a couple packages to help fix that imbalance. So first of all, I'll just import NumPy as NP, and I'll also import sklearn data sets. We'll import the make blobs. All right, and then we'll also import matplotlib.pyplot as PLT. And let's use our make blobs to create feature and label sets. Okay, so make blobs and the number of samples, and we're just going to give that a list of the number that we want, 2,000 in each, and the number of features is going to be equal to 2. Then we want to put the centers, okay, the centers of these blobs, we'll put them at -5, 5, and then put this, the orange ones at 5, 5. Okay, let's continue on. We'll have a random state so that we get reproducible but random results. So that's just our seed randomizer. And then cluster standard deviation is going to be equal to 3. So that's how much they're distributed. We want some overlap here just to be able to show those two crossing over. And then, so what if we generate that? Okay, sklearn. Okay, we're going to generate the features. All right, and then we also have our label. And that's going to be a 1 or 0, depending on it's supposed to be blue or orange. All right, let's go ahead and plot those though. We'll create a plot with a figure. I'll create this just a little bit bigger than is, I'll control the size. Okay, 6:3 should be good. And then let's plot each one with a different color. So I'm going to say the color value in, okay, range 2. So we're going to start off with a 0 and then a 1. And we'll just get the rows that correspond to the blue side. Okay, so that's going to be where, and we'll say label equals CV. So that's going to be a 0 or a 1, and then we'll scatter plot those, just those points. All right, just the rows that correspond to that, and then the very first column, these are going to be our x values, and then we'll also have our row with the next column over, those will be the second column, or the y values. And then let's just use CMAP equals paired. All right, and then after we're done, we'll give it a tight layout just so we get rid of the white space, and then we'll show it. Okay, we have argument figure, fig size. And let's see, what else we did? We did here, we got an unexpected. Okay, I need to say where it's equal to CV. I put a double equal sign there. All right, then we have our clusters that were plotted on this plot. Okay, so one way that we could reduce that, so I'm going to just change this down to 50 now. Okay, so we have this other data set, the orange, that has many fewer samples than the 2000 here in the blue. So now we need to fix that. One way to do that is to just undersample the majority set. And you can do that yourself. This one's perhaps just a little bit easier to do if you didn't want to have to use a package. You could say np where label equals 0, and then you could find all of the rows where that's the case. And then we're just going to say that's 0 just to get the array out of it. And then we could undersample it. Like, let's say we wanted to take every, let's see, we have 2000 and we had on one side and 50 on the other. So if we wanted to reduce that, we would say, let's take every, maybe, let's see, what would that be? 200? Let's see, no, 400. I'm trying to get this right. 400. Every 400. Okay, so that's going to give us, it should be 40. Okay, there we go. Okay, so we have our 50 there, and this is, we could have these rows then selected. Okay, so we could downsample the blue set so that it equals the number of orange points. And so I've just taken every 40th row that is equal to label 0. And so those are my blues, and these would be my new rows. Okay, so that's one way I could undersample. Fortunately, there's also a nice package that can do a lot of that for you to undersample or oversample. And so if you'd like to use that, by default, I don't think it's installed in most distributions of Anaconda. So you'll need to say pip install imblearn. We're going to use this package to do the undersampling or oversampling. And it says it's already satisfied, but if you do not have that, then just come up here and restart your kernel so that you can use that package. Okay, then you just need to do that once to install it. Okay, so let's come back here and let's add our classifier just to show where the classifier is going to pick out that boundary between the two. So I'm going to import, let's just use a simple classifier. You could use any, though, sklearn, and I'll do the linear model, import, and then logistic regression. Okay, now what I want to do is be able to perform the logistic regression, but I need to have this background plot here to show where the boundary is. And so I'm going to create a mesh grid of points, basically 0.1 intervals all throughout here, and then be able to plot a contour that fills in the color to show where the logistic regression is drawing the boundary between the two. So let's just first of all get the min and the max. Okay, and that's going to be for features. We're just going to have it for the first column, and then we'll get our min and just subtract 1 from that just to give us a little bit of space, and then also features. Okay, and we'll get the max from that as well. Let's just copy this, and this will be the second dimension, the y dimension, and that'll be in our second column. Okay, let's get a grid for each one, and that's going to be just do a range and min 1 to max 1, and we'll do it in 0.1 intervals. And let's do x2 grid, and we'll do the same thing. Okay, min 2, max 2 in 0.1 intervals. And then finally, we're going to create our mesh grid. Okay, mesh grid, and that will be x1 grid and y1 grid. Okay, that's going to create this, basically take every point from x1 grid and x2 grid and make a matrix out of it. So those two vectors, it's going to say I need to visit every x and y point. All right, now what we need to do is just flatten that because we need to evaluate every one of those. And so I'm going to do x and then flatten. So just take that two-dimensional array and make it a one-dimensional array. All right, and then I'm going to then reshape these into column vectors. Okay, so R1, reshape, and that'll be length of R1, comma 1. I think I can use a colon there as well. Let's see, that's going to be 1 here instead of 0, and then let me reshape the other one. And typically when you try to put those vectors in as a row vector into the package, it'll give you the little hint to say, hey, you need to do this to make it a column vector. Okay, so there I have the reshapes, and then I just need to create my grid, and I'm going to stack the two. Okay, I'll do a horizontal stack and do R1 and R2. So we haven't even gotten to the oversampling or undersampling yet. I'm just trying to create this background. All right, and now we'll have our model that's going to be the logistic regression. And so then I'm going to have the model fit. It's going to be the features and the label. Okay, and then let's go ahead and just add that to the plot. So here I have the points that I've included. Now what I want to do is go ahead and get my predictions, and that's going to be from the grid input. Then I'm going to have ZZ, that's going to be, I'll reshape this into XX shape. So the same shape as XX. I could have used the YY as well, should have the same shape. And then I'm going to plot the contour. YY and ZZ and CMap, let's make that paired. Okay, let's see, features is not defined. Let's see what I named that. It's called feature instead of features. I fix that. And features is not defined. Okay, I used that multiple places on features. Let me just go fix that. Features, it's just one feature here, singular. Let me see if that works. Okay, another error. Let's see, a range. I see that I put one too many R's there. Okay, Y1 grid. Well, I've got a lot of bugs here. Okay, so Y1 grid is not defined. I think I just forgot. Let's see. Let me see if I can find that. Oh, X2 grid. Not Y1, X2 grid. There it is. Okay, so I think I've got it worked out now. Here's the logistic regression result that shows the problem, which is that if we have fewer data points, even though the standard deviation is still the same, that the blue dominates this because it's trying to keep the same number, approximately the misclassifications. It's trying to draw this boundary to minimize the error of misclassifications for logistic regression or any other type of classifier. So it's going to draw that boundary naturally to favor the ones that have the most points. And really the boundary should be here. So let's go ahead and add to this. We're going to add this imblearn, and we're going to either oversample or undersample to get the results that we need. So let's first of all just try the undersampling. What I'll do is just go ahead and add here a imblearn. Okay, I'll do from imblearn pipeline. We'll import pipeline. All right, and then from imblearn undersampling, we'll import random undersampler as, and let's just shorten the name, RUS. Okay, so now we have our random undersampler, and so we have our logistic regression, but instead of just performing the logistic regression, we're going to create an undersampling strategy. And so let's go ahead and do that. We'll create the under, and that's going to be RUS, the random undersampler, and the sampling strategy is going to be majority. All right, and then we're going to have random state. Okay, again, just to initialize our random number generator is 47. And then let's create the steps in our pipeline. So this is how it's going to process things. It's going to first of all be this first tuple, U, and then under. All right, that's our undersampler. And then we're going to do our second one, which is, I'll just call logistic regression, shorten that name, and that's our model. Okay, so I'll create that as a model. Now I'm going to need to put this underneath the model creation. Okay, but I don't want this model fit anymore. I'll do that fit later. Okay, and what I'm going to do now is go ahead and create my pipeline. Okay, those are my steps, and my pipeline is going to be equal to pipeline with my steps. So it's just going to undersample and then do the logistic regression. And let's do pipeline.fit. So instead of model.fit, we're going to do pipeline.fit. And then this is going to be the feature, okay, the feature set, and then the label. Okay, and then this should, okay, now we just need to change the predict down here. So instead of model.predict, we're going to do pipeline.predict. And let's see if this gives us a better result. Okay, so it does. It undersamples the blue. It just removes those to be similar to the orange. Now the problem here is that you can see that this classifier is now skewed. It's kind of angled in this way. And that's just a function of just so few points. Now we're down to 50 points on both sides. It just has a hard time distinguishing an accurate angle here, whereas it should be straight up and down. But you can see it's moved over from the right to the left. Okay, so that's progress. But let's go ahead and just try a different strategy now. So instead of undersampling, we're going to oversample the we'll go ahead and oversample the minority set. Okay, so let's use the SMOTE. Okay, so from imblearn, we're going to import SMOTE, the synthetic. So let's see, SMOTE is, okay, synthetic oversampling technique. And what you're basically doing is you're taking similar points and generating new points around it that would represent as if you just collected more data. Okay, so I'm just going to come back here. So we imported SMOTE. I think everything else is similar. We don't need the random undersampler now if we don't want to use keep that in there. Okay, then I'm just going to change the pipeline now. Now it's going to undersample instead of oversample. So now I'm just going to remove that one and make an over. Okay, and that's going to be equal to SMOTE and sampling strategy equals minority. All right, and I'll just have my random state here just so I get reproducible results. And the k neighbors is like a k nearest neighbors where it generates from 3 nearby neighbors, this random point. Okay, and then we're going to change our steps. I'll just change the abbreviation of it to O, and then I'll change it to oversampling. All right, so this one, it improves it a little bit. The boundary is still here right around 0, but now you're oversampling the orange to give 2,000 data points instead of 50, and it generated those synthetically. So part of the problem with this is that you're going to make the classification much larger. So if the classification method really doesn't scale well with number of data points, then oversampling is potentially going to be bad because you're just going to be increasing the number of data points equal to the majority set. So maybe a combination of those two could work well. Let's come over here to now the exercise. So after these, we're going to come down to an activity where here's an imbalanced training data set. You can see it's just a CSV file, an imbalanced test data set, and we're going to open up this imbalanced notebook. So if you'd like to get it, just come over here. You can either clone the repository or right-click Save Link As, and then you can save the IPython notebook to your desktop. I've got it opened right here. You can also open it up in Jupyter, like Google Colab, and be able to run it online without installing Python. Okay, if you do not have imblearn, again, just go ahead and uncomment that, and you might have to get rid of the comments here because it typically just wants it just on its own line without any comments. Okay, and once that's satisfied, you can comment it out. And then also, we're going to use XGBoost here. So go ahead and install XGBoost, but it's you could use another classifier, okay? Or I can hit double D and it deletes that. Okay, so once you're done with it, you can just delete those cells. Okay, I'm just going to start with these packages right here with some of these already imported, and we're also going to develop a confusion matrix display and get an F1 score as well. Okay, so these are some of the things that we're going to need. We're going to import the data with the weighted classes. We have the imbalanced training set and the imbalanced test set. Okay, as part of our data, and then we're just going to plot how these are imbalanced. So we have 3 different labels, and you can see the imbalance of the 3. You only have 10 down here. You have about 120 or so, 130 of these, and then 800, a little over 850 or so on the majority one. So I think I only need 3 bins there instead, but if you want to just increase that so you can have a little bit of separation between them, then just increase it to 5. Okay, so here we have, our different data sets. It's really imbalanced, so we need to try to fix that. So let's first of all just visualize what we're working with here. Okay, and we can do that with a pair plot. Let's use the Seaborn SNS pair plot with our data and hue equals label. So we want to look at the different data sets. just with our 5 features. Okay, so we have 0, 1, 2, 3, 4. Okay, 5 features and then 1 label, and the label can either be 0, 1, or 2. So the dark one is the one with only 10 data points, and we're going to try to perform a classification to draw the boundaries on where 1 is, where 2 should be, and then 3. So these are the features, and you can see the distribution of these, and you can see that 2 is right in the middle of those. Not many on 2 at all. So very challenging imbalanced classification. We want to create the models, and we're going to weight them either by undersampling or oversampling. Okay, so let's first of all, let's see, we visualize the data. We want to find and okay, so we want to find and drop redundant columns. Okay, so let me just create some additional cells here. And so let's go ahead and just do SNS heat map, and we'll also look at how the data is correlated. And okay, so here's how the data is correlated. We have our label, and we want to see if it has a positive or negative influence by these other factors. All right, let's go ahead and count how many we have. I'll insert a cell below, and I'll do np count non-zero, and this will be my y train, and values equals 2. Okay, y train, I don't think I split that out yet. Let me go ahead and split that out into my different test and train sets. Okay, I guess I only have the data right now. Let me see. Oh, I know what I need to do. I need to first of all go ahead and split that out into my X train equals data, and I'm going to say that 0, 1, 2, 3, 4. Those are going to be my training data sets, and then my Y train is going to be equal to data, and then that's called label. And then my X test, that's going to be data T, and that's going to include those same labels there. And then Y test is similar, but it's just data T for the test, and that's Y test. Okay, so let me come back up here and just make sure I've got data head. Okay, 0, 1, 2, 3, 4 with my label, and let me also just do insert cell below with data T, and I can see those same columns and label. Okay, and let's see, what am I doing here that's okay, so I figured out what was going on here. I just forgot to rename my headings, and if you see up here, I had 0, 1, 2, 3, 4, and then label, and I just need to rename these. Okay, so let me go ahead and just do columns. Instead of a Boolean at the top, I need to have data.columns, and just name those. Instead of as strings, I'll have to do numbers here, 1, 2, 3, 4, and then label. Okay, and then data T dot columns equals 0, 1, 2, 3, 4, and then label. Okay, then when I run that, it doesn't change the results here or down below, but now I can go ahead and use these. Okay, so I've selected X train and Y train, X test and Y test. All right, and then what I'm going to do is go ahead and just count the number of non-zeros that are equal to 2. And so this is this one part of the data set. Okay, so this third category that has only 10. And so I'm going to just do the count non-zeros, and I'll say that ytrain dot values equals 2. And so let me just print FA. Okay, and it does not have any count non-zero, so it's just non-zero. So there's 10, and then I want to oversample this to get it up to 20. All right, so there's 20, and then let's go ahead and just do the oversampling, and I'll say that 0, I'm going to make that equal to integer, just to make sure it's an integer. It should count as an integer anyway, but let's do count non-zero, where ytrain dot values equals 0. All right, I'm going to put a comma here and just continue. And then for 1, category 1, I'll do the same thing. I'll just count non-zero with ytrain dot values equals 1. So I'll use those same numbers. I'm not going to oversample those at all. And then 2, this is the one that is the minority, and that's just going to be FA. So I'm going to double that to 20. Now let's do the undersampling approach, and this one's going to be 0. We're going to undersample all of them now to 20. So I'll just say 0 is going to be FA, 1 is going to be FA, and 2 is going to be FA. So they're all going to be balanced. They're all going to be equal to 20. And now let's go ahead and create our oversampling approach. Let's use SMOTE, and sampling strategy equals OV, random state equals 4, and K neighbors equals 4. Let's use our undersampler now. This one's going to be RUS, and sampling strategy, okay, is going to be undersample. Okay, and I have those target values. And now I'm going to say random state equals 4. So instead of sampling strategy equals majority or minority, I'm actually putting the number that I want here. Now my model weighted is going to be XGBoost, and XGBoost classifier, and we'll use label encoder equals false. And then my imbalanced, okay, IMB, I'm going to say that's going to be XGBoost. So I'm going to compare these two with balanced or unbalanced results, and then we'll use a confusion matrix to look at both of them. Okay. Now let's do our IMB imbalanced, and we'll just fit that just with the data that we have. Okay, the training data. And then we're going to have some steps for the other approach. So this is the imbalanced one. Let's go ahead and just do the model weighted. This one's going to be the balanced one. And so we'll have steps equals 2. And first of all, we'll go ahead and oversample the minority class. We're going to bring that up to 20. And then we're going to undersample all of them back down to 20. So any of them that are over 20, we'll sample those back down. And our classifier is going to be XGBoost with our model weighted. Okay, so there are our steps. And then we're going to build a pipeline now, just with our steps. And then we'll fit this one, just like we do with the imbalanced. Okay, so here we have X train and Y train. All right, and I'll go ahead and run this, and it's going to give me some warnings here. It's going to show me my XGBoost classifier. Okay, now we're going to go ahead and just plot these. Let's go ahead and just do the confusion matrix to display these and visualize the results. So we created our models. I guess I should have moved this up. And now we want to visualize. And for this one, we'll do confusion matrix display. And we'll use from estimator. And we'll do the model IMB and X test and Y test. Okay, so here is our estimator. Now this is the imbalance, and you can see that it had many misclassifications here in this lower diagonal. Okay, so what we want to do now is go ahead and do the estimator with our pipeline instead. Okay, and this one's going to be balanced. And this is going to be the same X test and Y test. Okay, so you can see here it's more along the diagonal. Okay, so it did a better job overall of not having a majority of the errors down here. But you can see quite a few misclassifications. And this was actually a very challenging classification problem. You can see how much overlap there was, right up here in the beginning. They're just kind of all on top of each other. Okay, so the clusters have a large degree of overlap, and there's only 10 data points here that we're using to try to pick out that number 2. Let's go down and just see if that one's underrepresented here. So in the training, we can see that this is the predicted label right here, and this is the true label. So it predicted 1 when it was actually 2, and it predicted 0 when it was actually true that many times. And you can see the misclassifications this way as well, where it predicted it to be 2, but it was actually a 1, and it predicted it 2, and it was actually a 0. So overall, the distribution of these is more balanced, although this classifier is still, just due to the nature of the data, it isn't going to come up with very good results anyway. Okay, so that's it on imbalanced classification. There's additional information here, and there are also some very nice additional readings and references down here to learn more about imbalanced data and how to deal with it, how to undersample a majority set or oversample a minority set.